Hello and welcome to Section 6. This is the last and final section of Riverbed's RCSA exam preparation module series. I'm Bob Ashmore. I'm a Channel SE with Riverbed. Let's get right into Section 6. Section 6 starts with steelhead troubleshooting. Basically what we're going to do here is figure out where there's problems in our steelhead deployment and how to identify how to resolve them. First, we could have cabling issues. The symptoms might be there's either no connectivity or when there's connectivity when the speed and duplex is set to auto, but not when it's hard-coded. If we go through the troubleshooting process, we notice that the connected router and switch ports show down, the steelhead ports show down. The likely problem is that the cabling is incorrect. Remember that we use a straight-through cable when connecting to a switch, and we use a crossover cable when connecting to any other type of device, as is shown in the graphic to my upper left. Next, let's look at a connectivity issue wherein we have failed to wire. So everything's functioning correctly, but then if somebody pulls the plug, the power wire on the steelhead appliance, then there's no connectivity. When we look at troubleshooting, we notice that the route and switch ports show that they're down when in fail to wire mode, and the steelhead ports always show link down when the hardware is failed to wire. The likely problem again is that the cable is incorrect or that we have a speed mismatch problem. So what we want to do is change the cabling, as previously discussed, to use a straight-through cable with a switch and a crossover cable when connected to a non-switch, and then make sure that the LAN and WAN speeds are the same. Oftentimes, people will use auto on the LAN side and then 100 meg on the WAN side, which will work fine when the steelhead appliance is functioning, but in a fail-to-wire situation, we're going to get a speed and duplex mismatch, as all of us know. Next, if we have a loss of connectivity of over 45 seconds when failing to wire. The likely problem if you've ever taken any Cisco exams, whenever you have a problem that takes 45 seconds, you're referring to a spanning tree reconvergence. So while spanning tree is converging, we have to wait 45 seconds. To make this go faster, what we can do is enable port fast on the switch port that the steelhead appliance is connected to. Enabling port fast allows the convergence to happen quicker. Also, we can disable spanning tree on the port that the steelhead appliance is connected to. However, make sure that there are no loops. I do not recommend that. Or use rapid spanning tree, RST. Next, problems with VLANs. So there's no optimization on the steelhead when we're trunking VLANs across the WAN link. Remember, as we covered in a previous section, that it's critical that the 802.1q trunk has the same VLAN ID tag that matches the IP address of the inline interface. Remember that we will optimize the traffic on all of the VLANs. However, we need to ensure that the in-path interface is located on a proper VLAN. Sometimes you will have no optimization at all. Now we can step through the process for testing this, and the best thing to do is to start by pinging between the two steelheads. Now, if we drop to the CLI and we use the simple ping command, that's going to ping by default out the primary interface. In most situations, we're talking about an in-path deployment, so we want to ping between in-path interfaces. So we do that by using the capital I. So we ping minus capital I, and we use the source and destination in-path IP interfaces for that ping. If the ping works, then we should test to make sure traffic over port 7800 can get through. Sometimes a firewall has been configured to block port 7800, either unintentionally or maliciously. In order to test connectivity over port 7800, what we should do is telnet. The key here is the switch -B. -B allows you to specify the source and destination IP addresses of the in-path interfaces and to specify that we want that conversation to go over port 7800. If you get a connected, then a blank screen, then port 7800 is working. If there is no response or you don't get connected, then port 7800 is being blocked. Another way to troubleshoot traffic traveling between two steelheads is to run a trace route between the two in-path interfaces. We do that by using the -S switch. So it's traceroute -S and then the source in-path interface IP address and the destination in-path IP address. I'm sorry that those switches are all different, but we got these straight from Unix and did not want to change them for those of you that are familiar with the switches in Unix. Next, let's talk about one-way optimization. Traffic is being optimized in one direction, but not the other direction. You would be amazed at how often this happens. The cause of this typically is that the LAN and WAN cables are reversed. Remember from way back in section 2 or 3, we talked about auto discovery, and we talked about how auto discovery only works when naked SINs show up on the LAN port. So if the cables are reversed and the WAN port is connected to the switch and the LAN port is connected to the router, then we're going to have SINs showing up on the WAN port, which will not be optimized, and we will only see optimization of traffic that's coming into the steelhead, not going out. Another problem is maybe auto discovery is not working. You may be using some type of device, either intrusion prevention or intrusion detection. Maybe you've got some kind of a firewall or a satellite network which is stripping your TCP option field. In that case, we're going to be losing our auto discovery probe, and we need to use a fixed target rule. Why does a fixed target rule work when auto discovery does not? Because fixed target rules do not use probes. We define exactly where that connection should terminate the steelhead appliance's IP address. Next, speed issues with duplex mismatch. After the steelhead is installed, nothing goes any faster. We would see optimization. It would show that the connection is being optimized, but it's not going any faster. That's because typically the speed or duplex is mismatched where the steelhead is connected to the router or where the steelhead is connected to the switch. We may also have the same problem somewhere else. I've personally run into this where I had a client box that was connected directly to a phone, and that phone was wired at 10.5 or something like that. So we had a speed and duplex mismatch there. It could happen somewhere other than what's directly connected to the steelhead appliance. It could happen anywhere in the data path between the client and the server. We already talked about packet ricochet. Basically, if you see performance is not as fast as you would like it to be, then we need to make sure that we turn on simplified routing or enable static routes and define those on the steelhead appliance. SMB signing. If SMB signing is configured, for example, if you've got a Windows 7 client that's talking to a domain controller, then SMB signing is on by default. And if you haven't configured SMB signing on the steelhead appliance, you're going to see a red triangle and you will see a lack of optimization. We will fall back to LZ, SDR, and transport protocol acceleration. So what you'll see in the logs is the error here, SMB shutdown, error sexsig required, or you'll see that red triangle in the diagram for the current connections. Next, we want to make sure we look at the syslog. There are multiple logging levels. The default level is notice. Make sure that we know that. And we'll want to take a look at the syslog to see what's going on there. So basic stuff that we already covered. Make sure that the cables are correct, you get speed and duplex correct, and that WAN 00 is connected to the router, LAN 00 is connected to the client. We want to make sure that configurations are correct, and we want to define that the LAN and WAN topology is as was expected. If you ever talk to Riverbed technical support, they're going to ask you for a system dump. System dump basically collects all of the information about the current state of the steelhead appliance, and it can be run through a sysdump analyzer by the technical support staff. We go into reports, diagnostic, system dump, and this is where we are able to either generate a system dump or download a system dump that has been created. When we take TCP dumps, a TCP dump is the ability to collect packets directly off of the wire. Sometimes we need to take TCP dumps because we want to try to optimize traffic that is not currently being optimized, and we need to look at what that traffic is. In some of those situations, we want to try to get the entire payload of the packet. In that example, we're going to want to use the -S switch. The -S switch specifies the size of the payload and where it should be truncated. We either want to use an S0 to mean don't truncate it, or a large enough integer after the S that will give us the amount of information that we need out of the payload. There are a number of CLI commands on here that we recommend that you know. Some of them that are critical are restart and reload. Make sure you know the difference between those. Restart restarts the optimization service, whereas reload will actually bounce the appliance entirely. The clean added to the end of restart or reload means to wipe the data store, which is commonly used in a proof of concept where we want a clean data store. Notice that some of the ways to get the boot image, or to show boot far, or show images, there's a number of other commands here that are very helpful for you to know. All right, that's Steelhead appliance troubleshooting. Now let's look at Steelhead mobile troubleshooting. From the PC, we can access the client software and go into the support tab. There's a lot of cool things you can do here. You can view the logs. You can upload the logs to the controller for a system administrator to analyze. We can also generate TCP dumps and run a diagnostics check. We can restart the services. You can reset your policy if maybe you were playing with it and somehow nothing's working now. You can reset it back to the policy that was originally deployed by the administrator. And we can also configure which Steelhead mobile controllers we're talking to receive licenses and so on. Some other issues are the things that can happen on the Steelhead mobile client. One of the biggest problems we run into is the PC firewall. Remember, by default, the PC firewalls are blocking port 7801, which is critical for Steelhead Mobile. So we need to make sure we go in and allow port 7801 so that we can optimize traffic. Also, on the PC, there is a command you can run. It's rbtdebug.exe, and you can watch the information that's generated and placed into a trace file that is located in the file location that's specified at the bottom of this slide. All right, well, that's the end of section 6, which is the end of the collection of videos we've produced for this RCSA exam preparation. Thank you for taking the time to look through this, and good luck on the exam.